question talks about a semicircle, so let's look at a semicircle. Do the best to draw it reasonably well. Now, I've discovered that what they like to do when they talk about the perimeter of the semicircle is they include the line that goes through the center of the circle. So you've got that there and that bit there. So first of all, we need to work out what that bit is. Now we're given the area of all that lot there, half the circle, as being 50 square meters. Now that's quite a size. What is the equation for the area of a circle? It is pi r squared. Now you really need to know these. The circumference all the way round of a circle, that's this bit here and the bit that would be underneath. Alright, so this circumference pi times the diameter. If you consider the diameter as a radius, radius, this bit here, where are we? Bring that down there. If that bit there is your radius, then it's also the same size here, and here is your diameter. Then 2 lots of radius equals the diameter. So you can write that as pi times 2 lots of the radius. Now normally you wouldn't write it like that, you'd write it this way, 2 pi r. Right, now this here is the same as that. So we have our references there. Now what information have they given us to start with? We know that the area is pi r squared. We don't know what the radius is, so we need to find out what the radius is. Pi is commonly available, and we're told the area is 50. So we have here, using equation 1, right? That's equation 1. Call it equation 2. So using equation 1, we have the area, which is 50 square meters, is equal to pi r squared. Now this is the second recording. When I did the first one, I embedded one equation inside the other, and I thought, well, that's getting a bit too complicated for, or too involved for functional skills. So I'm going to shift to using numbers, but we have to be careful because it talks about rounding it. Now as soon as you involve numbers with pi, you can't help but round it and you introduce error. So we've got to try and reduce the error to a reasonable level. We're told that 50 square meters equal to pi r squared. So in fact this is 50 square meters equal to, now I'm going to put the r squared here, times whatever value pi is. That ringing you can hear, there's a chap that comes around in a van selling chips. Right, pi, the value of pi. Now look, on the calculator, where is it? There it is, in brown. So we need to press the brown button to get pi. And we have that as the answer. Now I'll change that to decimal, and we get 3.141. Now it is quite common to round it at that point there. Now because the number to the right of where it is rounded is greater than or equal to 5, we round up the 5. So this becomes 3.1416. We're going to use that number there, times 3.1416. Now this is to 4 decimal places. There's 1, 2, 3, 4. So it should reduce the error to some extent. So now we have that. Now we want the value of r squared. This is multiply. the shortcut method. If something on one side is multiply, whatever it is, you know, we take it over to the other side and it becomes divide. So we're going to take that 3.1416 over to this side here, that's multiply, becomes divide, so it goes underneath, so we end up with 50 meters squared over 3.1416. Okay, so we end up here with 50 meters squared all over 3.1416 equals, now because we've moved that over to the other side, all that we're left with is the r squared. See, the first step is to isolate or get on its own the bit with r in it, which we've done. Now we want to get rid of the square. Look, we know that 2 squared is equal to 4. If I square root 4, I get 2. If I square root that, I must get the same value. So what it amounts to is this action here undoes that action there. It cancels it out, gets rid of it. So to get rid of that there, to have r on its own, we need to square root this side. Right? Let's just get rid of that. So we have here, I'll write it out though. I'll write it out. The square root of r squared is equal to the square root of 50 meters squared all over 3.1416. Alright, that's rounded to 1, 2, 3, 4 decimal places. Alright, so we have this condition here. To get the r on its own, we square root it. So if we square rooted the right, we square root the left. So we want the square root of that lot, and that will give us the radius. Pull up my calculator, clear that lot. We have, we want the square root of that, don't we? So square root of 50, it's not, you don't square the 50, that it's just the meters there that's squared. It's telling you that that is 50 square meters, so it's 50 divided by 3.1416, come out of the square root, and that will give me a value. Now again, you see, we're beginning to introduce errors. As soon as you do this, it produces errors, which is why it's better to use algebra until the very end. Okay, so we reckon this, oh, I lost it. What was it? 9894.9894. Now, you see, because this isn't precise, it isn't exact, it's an estimate. But it's a good enough estimate for what we want. We've now found the value of r, the radius. We now have the radius. We've got part of what we need. The radius is half the diameter. Right? D over 2 equals r. So we can find D. But don't forget, that's the circumference of a whole circle, the whole thing. Right? So if we just double the radius, we get the diameter. Double the radius, we get the diameter. So we need to double that. And go back to white. Our diameter, which is twice that. If you multiply the right by 2, you multiply the left by 2, is twice that. Now look, here we go. Look, we got 3.9894. Twice that, multiplied by 2, and we get that. 9788. 8, what was it? Get it right. 797. French 7. That's our diameter. So now we've got part of equation 2. So we know that circumference of a full circle, a whole circle, is pi times the diameter. So we multiply that by pi, we get pi times 7.978. Remember, this is rounded, so it's approximate. Will give us the the circumference of the whole circle, all of it. It is the whole circle, all the way around. We only want half, but we've got to add this bit that goes across as well. Alright, so we have this here, and let's do that, shall we? There's our double, multiplied by pi. Look on here, pi is brown, so we want the brown, the shift. I shouldn't necessarily have done that. Delete. Okay, times. I nearly forgot. Times shift pi. We don't need to do the decimal because it will do it for us. Pi times the diameter is that. 25.0661 equals 25.0661. I know the decimals go on, but we're stopping at 4 decimal places. Now that is all the way round. We only want half of it. So now we divide that by 2. So we have, where's the calculator? Lost it. That's this, divide it by 2, and we get 12.533, round it, say 1. Okay, so 12.5331, 12.53331. Now that is halfway round there. But we also need to include the bit that goes across this part here. And we know that is twice r, or the diameter. That's the diameter there. So we go all the way around and across. And across bit is that. So we need to add to this so that this is half the circumference. I haven't got room. I'm going to stop there. That's half the circumference, this bit. Now we need to add that bit, which is this. So we have 7.978. Put a line underneath and we're adding those. 8 plus 1 is 9. 8, 11. Carry the 1. 8, 11. Hang on. 8, 9, 8, 9, 10, 11, carry 1, 7, 8, 11, yep, carry 1, 10 and 5, 15, carry 1, 8 and 2 is 10, so that's 20. So, and don't forget the unit of measurement is meters. So all the way around there, and then across on this line here is that. Take your time, think about what you're doing. Now we've got the number. Now we've got the number. Let's go back to the question and have another look. Give your answer correct to 1 decimal place. 1 decimal place. All right, let's just change the color again. So the cutoff point is there. The number immediately to the right is 1. Now it's less than 5. Because it's less than 5, we don't round that up. So the answer is 20.5 meters, don't forget to write to 1 decimal place. That is your answer.